we're going to predict the products of this reaction and write all three types of equations for it. So I'm going to start with the molecular equation with what I have going. This is a double displacement reaction, and I can tell because I have two ionic compounds that are combining. They're both in aqueous solution. Okay, so what's going to happen is that the positive part of one, or the front part of one, will go with the negative or back part of the other. So in other words, I'll have copper go with the sulfide, and then again the front of this one with the back of that one. Okay, and when I switch those, I also need to look at the charges and make sure these are good good formulas for those compounds. So let's figure out the charges that are over here. Chlorine is in the -1 column of the periodic table, so this copper must be +2. Here, sulfur is in the -2 and sodium is in the +1. Okay. In double replacement reactions, the charges do not change. So even though copper can be copper 1 or copper 2, this is copper 2 here, so in the products it will still be copper 2. So we can see in this case the formula is just kind of worked out for us. We predicted the products. Now we need to, let's go ahead and balance. So when we balance, let's see, just find something that's not balanced. Looks like the sodium is not. We'll balance sodium. And then next, we'll balance what that just affected. That just affected the chlorine, so we'll go 2 chlorine. Over here we have 2 chlorine, 1 copper, 1 copper, 1 sulfur, 1 sulfur. Looks like that's all balanced. And then the last thing we need to do is to decide on our states. Since this reaction does occur, we were told, I know that one of the products has to be either a precipitate or a covalent compound. Well, these are both ionic compounds, so one of them has to be a precipitate, and by knowing my rules about water solubility, I can decide which one. I know that sodium is one of those ions that is the compounds are always water soluble. So I know this one is aqueous, and so by elimination, this one must be my precipitate. Okay, and so I think we've done everything we can with that one. Let's go on to our complete ionic equation. So in the complete ionic equation, you'll break apart anything that's a strong electrolyte. And so for ionic compounds, it'll be anything that's aqueous, and ionic will be split apart into ions. So I'm going to just start here at the beginning. And then when I get to my precipitate, I'm going to keep it together. And notice, you've probably noticed, I'm leaving off these numbers because I wanted to show you where they come from. So because when I break apart one of these copper chloride units, I get 2 chloride ions, I need a 2 right there. And because when I break apart these 3 ions, I have 2 sodiums and 1 sulfur. And then, so that's good. And then on this one, notice that I have 2 sodium chloride units. So that will break it, multiplies through, that will break into 2 sodiums and 2 chlorides. So if I've done my numbers right, this should still be balanced. Okay, and it is. So next thing let's find our spectator ions. Spectator ions are in the same form before and after the arrow. So in other words, I see that sodium, there are 2 sodium ions that are aqueous before and 2 sodium ions that are aqueous after. And same with chloride, I see that that did not change. And so those are our 2 spectator ions. The other 2 changed because copper was by itself before, and then after it's in a compound. So those are my spectator ions. My last step is to write a net ionic equation. And in this case, what I'm going to do is just take my complete ionic equation and leave out my spectator ions. And again, if you did this right, it should still be balanced.